Today we are going to look at structure padding. In the last class, I gave you introduction to structure, and I showed you the size of a particular structure. So today we are going to look at structure padding. So what does this mean? Just like saying padding in our budget. So padding is simply the addition of extra byte, right? So let's create a structure. So I say struct using the struct keyword book, right? Um, Members will be what? Char, title. Then I'll put here, let's put 10. Then char, author, the author of the book, let's give it 20 bytes. Then here I will have double, and I will have price. Here I will have int pages. So I close this. Okay, so this is my structure. If I ask you for the size of this structure, what will it be? So this one will give us what? 10 bytes. Because character is what? 1 byte. Character equals to 1 byte. So for 10, then we're having 10 bytes. 20, we have 20 bytes. Right? Then double will be what? 8 bytes. And then integer is what? 4 bytes. Now, modern compilers align data in memory for quick access. So if you look at this, if I ask you now the size of this struct to be what? 42. That's what you will tell me. Right? But if we check size of struct book, right? This will give us 48 bytes. Why? Because of what? Padding. So this is the correct answer. If you leave it like this, no issue, but your application will be slow, right? Because it will take multiple access for the processor to be able to access the data in the memory and then max them together. So another rule is that compiler will do this alignment based on the alignment of the largest member, right? And the largest member in this now is what? Double, which is what? 8 bytes. So it's going to do it in the multiple of 8. So 42 is not multiple of 8. So what will it do? It's going to, the next multiple of 8 is 48. That is why it's giving you 48 bytes. So how is this going to happen? To access this price, for example, let's say I create a variable for this my struct. I will say struct book. Let's call that variable book 1. Book 1. If I want to access price, it will be what? Book 1 dot price. But how will the compiler know this, the location of this price in the memory? That will be what? Base address. Base address plus offset. Offset of price. So offset simply means the position of price from the base address. So if we have something like this, and the base address is 100, and title is here, right? Author is here, and price is here, and then page is here. So the position of this price, which is this field, from this is what you call the offset. Now, how would the compiler do this calculation? 10 bytes, of course, is aligning. It's going to align the data. 10 bytes will be aligned in what? 10 bytes. 20 bytes is in 1 byte, so there will be no need for any padding. So it will just increase it to 30. So that will be what? 10 plus 20, that is 30 bytes, right? 30 bytes. But when you want to fix this double, which is what? 8, it has to be done in the boundary of 8 bytes. So this 30 is not multiple of 8. So in the boundary of 8 bytes, you have to add additional 2 bytes in order to get 32, which is what? The multiple of 8. So it means that where you are going to start this price from will be what? At this point. So the address of price in the memory, if the base address is 100, will be what? This 32 plus this. That will be what? 132. Right? Now, 132, 8 bytes, it will count up to 139. It means that pages will start from 140, since it is 4 bytes, to what? 143. Now, that gives you 0 to 0 to 43. The pages will start from 140 to what? 143, right? Now, that, so you are having 0 to 43. That is from this place to 43. So that will give you what? 44 bytes. That will give you 44 bytes. But this is still not in the multiple of 8. So you need to add additional 4 bytes to give you what? 48 bytes. So that is how it will arrive at that answer of 48 instead of 42 bytes. So that is the concept of padding. So, but there is another important point I want to make you see. If another rule is that when you are arranging these your members inside this structure, let it be in descending order, meaning the highest one should be at the top. So this price should have gone to the top, then followed by what? Integer, then followed by character and character. It will save memory. But if you try it here, it might probably still give you the same output. So I will give you this as an assignment. Struct, let's call it bad, right? And then we say char A int B char C. Then I'm going to close this one. Then I have another one. So I have this another one, struct good. Then int B char A char C. Then I'll close this. So what will be the size of this one and what will be the size of this one? Because this is starting at the top, followed by this, followed by this. So this one will probably give you, let me not tell you. So let me just give you as an assignment. So tell me in the comment section, what will be the size of this character, of this struct, and what will be the size of this struct? Same element or same members. Char A, int B, char C, int B, char A, char C. But I arrange them differently. So what will be the size of this one? What will be the size of this one? So let's go to code block. Let me demonstrate them for you to see. But before then, tell me in the comment section. All right, so this is our code blocks. Just to show you the calculation. So this is the first one I did, structure padding. So this is the structure that we created. First, we want to find out the size of this structure. And then what I gave you as the assignment, this is it. So the bad and the good, we are going to look at what the value of this will be and what the value of this will be. And then that would tell us which one is the best, based on what I taught you, that it's always good to arrange them in descending order from the highest data type to the lowest data type. So that will help save memory space. So we are going to print out these 3 sides of the struct. So let's run this and see what the output will be. Okay, all right. So the first one, which is this one, is giving us 48. I've explained why it is 48 instead of 42 on the board for you to see. This one, char is what? Char is 1, int is 4, and the char is 1. So that should be what? 1, 4, 1. That should be 6, right? But it's not going to be so. Now, using padding, we are going to look at the alignment. Integer is the highest here, which is 4. So if this is 1, trying to access 1 will add additional 3 bytes, making it 4 bytes plus another 4 bytes, which is 8, plus another 4 bytes, that is 12. That's why you're having 12. Now, when you make int the first one, so that will be 4 bytes, then this one will take the boundary of the next byte, that is 1 byte, that is 5 bytes, then another one again, making 6. Now, in the multiple of 4, so you need to add additional 2 bytes, that will be 8. So that's why you are seeing 8 here. So it is better to use descending order, the highest to the bottom. So based on this, same elements, right? Same members for this bad and for this good, but different memory size used, 12 and 8. So that is why I'm saying that it is better to arrange it this way to still speed up access and then also help to minimize memory consumption. So that is what I want to show you in this class. So till we see in the next class. Bye-bye.